The sky is infinite, no beginning, no end, like a dream scene in sleep that never truly ends, even after waking each morning. How vast is this sky? How far does this cosmic ocean stretch across the universe? For thousands upon thousands of years, humanity has lifted its head skyward and simply gazed at the stars with wonder and curiosity. But now, humans have gathered the courage not just to observe, but to measure the immeasurable. Recent scientific estimates suggest that the observable universe is approximately 93 billion light-years wide. Now, imagine light itself, which travels at an astounding 300,000 kilometers in a single second. If it continues moving without stopping, without tiring, the distance it covers in 1 year is what astronomers call a light. So 93 billion light-years. This is not merely a number. This represents the outer boundary of human imagination and comprehension. It's entirely possible that beyond these limits, the universe extends even further into realms we cannot yet conceive. Asterisk, our Earth, our Sun, our planets, asteroids, and comets. All of these celestial bodies are part of a small cosmic family called the solar system. And this solar system is just a tiny member of a galaxy called the Milky Way. The Milky Way is a celestial city adorned with billions upon billions of stars. Billions of stars sparkle and shine within its spiral arms, and there are countless other galaxies like this scattered throughout the cosmos, each one hiding innumerable mysteries within themselves. Each galaxy is a universe unto itself, containing stories that span billions of years. Asterisk, there was a time when scientists Harlow Shapley and Heber Curtis engaged in what became known as the Great Debate about the size of our galaxy. Shapley claimed it was 300,000 light-years across, while Curtis argued it was only 30,000 light. What was the truth? Time provided the answer through careful observation and measurement. Today, astronomers believe the Milky Way is approximately 100,000 to 150,000 light-years wide. But the universe is many times larger than this single galaxy. How large exactly? Nobody knows for certain. Yes, each new estimate, each new discovery opens a window to fresh possibilities and deeper questions about the nature of reality itself. Asterisk. But how do scientists and astronomers measure such vast, incomprehensible distances across the cosmos? There are several sophisticated methods for measuring these enormous distances. One primary technique uses radio waves. Scientists send out radio waves from powerful telescopes and wait for them to bounce back from distant objects. From the time it takes for these waves to return, they can estimate distances with remarkable precision. This systematic process is called the cosmic distance ladder, a series of methods by which astronomers determine distances to celestial objects. In Puerto Rico, there stands a massive telescope called Arecibo, one of the largest radio telescopes ever constructed. But the universe is so incredibly vast that even radio waves become limited in their effectiveness beyond certain distances. Asterisk, that's when another phenomenon becomes crucial. As stars and galaxies move away from us due to the expansion of the universe, their light begins to shift toward the red end of the electromagnetic spectrum. Through careful analysis of this redshift, astronomers can understand how far these celestial objects are from us and how fast they're moving away. This discovery was revolutionary in understanding the expanding nature of our universe. Asterisk, in a brilliant female scientist named Henrietta Swan Leavitt made a groundbreaking discovery that would change astronomy forever. She discovered a special class of bright stars called Cepheid variables. The brightness of these stars tells us precisely how far away they are. They serve as cosmic lighthouses, allowing us to measure distances across vast reaches of space. Based on this fundamental discovery and subsequent refinements, we know today that the Andromeda Galaxy, our neighboring galaxy and the closest large galaxy to the Milky Way, is approximately 2.5 million light-years away from us. That means the light we see from Andromeda tonight left that galaxy 2.5 million years ago, when our ancestors were just beginning to walk upright on the plains of Africa. Asterisk, but will humanity ever truly know how big the universe actually is? Perhaps not, and here's why. The universe is constantly expanding. And not just expanding, but accelerating in its expansion. What scientists measure today has already become even larger by the time the measurements are complete. Imagine a balloon with several dots marked on its surface. As the balloon inflates, the distances between the dots begin to increase. Not because the dots themselves are moving, but because the space between them is expanding. The same thing is happening with our universe on an incomprehensibly larger scale. Asterisk, a star that's shown 14 billion years ago, its light is just reaching us now, having traveled across the expanding cosmos all this time, and now that star, or what remains of it, is approximately 46.5 billion light-years away from Earth. Try to imagine how rapidly our universe is expanding, stretching, growing larger with each passing moment. The space itself is being created, pushing everything apart. Asterisk, so when we look at the night sky, we're not just looking at stars in their current state, we're peering into time itself, looking into the past. Every point of light is a bygone yesterday, a past moment frozen in time, a memory that still shines today. And in this endless expanse, our Earth is just a drop in an infinite ocean, a fleeting moment, merely one story among countless billions. But it is this story, this tiny pale blue dot, that gave humanity the desire to reach for the stars, to explore, to understand our place in this vast cosmic arena. So let's look at this infinite sky once again. With fresh eyes and renewed wonder, perhaps something new will reveal itself today. We are about to embark on an infinite journey through this universe. A voyage that will take us from our familiar Earth to the edges of the known cosmos and perhaps beyond. This journey will test the limits of understanding and challenge perceptions of reality itself. Preparing for launch *, put on headphones for the full immersive experience. Turn off the lights if that helps create the right atmosphere. This journey requires full attention because where we're going, distractions have no place. There's too much wonder to witness, too many marvels to behold. Now we are about to take off, launching from our home planet into the infinite void. We are ready for takeoff. From the spacecraft window, far below, the blue planet is visible, pulsating with life, glowing like a jewel in the darkness of space. Earth, home to billions of life forms, the only place in the known universe where life definitely exists. Now we will cross the atmospheric layers, one by one, peeling back the protective blankets that make life possible on our world. The first layer is the troposphere, which extends from Earth's surface up to approximately 12 kilometers in altitude. This is the realm where we travel in commercial airplanes, where weather happens. Clouds, rain, storms, lightning all form here in this active layer. The temperature decreases steadily with every kilometer of altitude gained, dropping roughly 6.5 degrees Celsius per kilometer. The color here is light blue and white, with wispy clouds floating like cotton in the sky. Next comes the stratosphere, which begins at about 12 kilometers and extends to roughly 50 kilometers above Earth's surface. The ozone layer exists here, that crucial shield that blocks the sun's harmful ultraviolet rays from reaching Earth's surface. Without this protective layer, life as we know it could not exist on land. The weather here is extremely calm, almost no turbulence, no clouds, just thin air. The color is a deeper, richer blue, and the sun appears extraordinarily bright and intense, unfiltered by the thicker atmosphere below. Now we enter the mesosphere, extending from 50 to 85 kilometers above the surface. Here is where meteors burn up, creating those spectacular shooting stars that people make wishes upon. One by one, glowing streaks appear as space debris enters the atmosphere and incinerates from friction. The temperature drops dramatically here, plummeting to minus 90 degrees Celsius or even colder. The color is black with just a faint blue glow at the edges. We're at the boundary between Earth and space. The thermosphere extends from 85 kilometers to 600 kilometers in altitude. Here is where the spectacular auroras appear, the northern and southern lights. Dancing colors of green, purple, blue, and red shimmer and wave across the sky, created by solar wind particles colliding with atmospheric gases. Space stations and the International Space Station orbit within this region. The temperature here is paradoxically very high, sometimes exceeding 1,500 degrees Celsius, but the air is so incredibly thin that this heat cannot be felt. There simply aren't enough molecules to transfer the thermal energy. The threshold of true space begins here. This is where the distinction between sky and space becomes clear, where Earth's atmosphere finally gives way to the void. The exosphere extends from 600 kilometers to approximately 10,000 kilometers. This is the outermost layer of Earth's atmosphere, where atmospheric particles are so sparse they can travel hundreds of kilometers without colliding with one another. From here, Earth's gravitational pull begins to fade noticeably. Now we are in space, the true void. The atmosphere is so thin that even individual molecules are rarely encountered. The color here is deep, absolute black, punctuated only by the brilliant points of distant stars, satellites and orbital infrastructure. What you're seeing now are geostationary satellites, positioned at an altitude of 35,786 kilometers above Earth's equator. These technological marvels rotate in perfect synchronization with Earth's rotation, appearing to hover over the same spot on the surface continuously. They're used for weather monitoring, television broadcasting, and communications networks that connect the modern world. These satellites are the unsung heroes of global connectivity. Before this, the smaller satellites visible were Starlink satellites, part of a massive constellation positioned about 550 kilometers from Earth's surface. They move in organized lines across the sky, shining like a string of pearls, as if someone has adorned Earth with a luminous necklace. There are thousands of these small satellites, creating a new kind of artificial constellation that's changing how humanity accesses information. The International Space Station orbits Earth every 90 minutes, completing roughly 16 orbits each day. Scientists and astronauts inside are working in zero gravity, conducting experiments that cannot be performed on Earth. studying everything from the human body's response to weightlessness to the behavior of flames and microgravity. Sunrise and sunset occur every 45 minutes for them. Imagine experiencing 16 sunrises and 16 sunsets in a single 24-hour period. The astronauts can see our spacecraft now. Perhaps they're looking our direction, wondering about our journey. They might be watching us through their windows. These brave explorers who've already left Earth's surface behind. But we cannot stop to visit. We have embarked on a much longer journey that will take us far beyond their orbital home. *##. Journey to the moon. *. Look ahead there. Suspended in the darkness is a silent piece of cosmic real estate that looks almost Earth-like from a distance. But as we approach, the differences become starkly apparent. No air, no sound, no atmosphere to carry vibrations. A silence so complete that only space itself can understand its depth. We are slowly moving toward our moon, Earth's only natural satellite, our constant companion for billions of years. *. The moon's surface is not the pure white that it appears from Earth, but rather gray-slate and ash-colored. Like ancient volcanic rock, the surface is filled with craters, one after another, impact scars from billions of years of cosmic bombardment. These are like the marks of time itself, the moon silently holding history within its scarred face. Each crater tells a story of violence, of rocks hurtling through space at tremendous velocities and smashing into the lunar surface with incredible force. *. This is exactly like Ashwathama from the that immortal warrior whose wounds never heal, who is cursed to wander forever bearing his injuries. The moon bears similar eternal wound craters that will remain unchanged for billions more years in the absence of weather, water, or geological activity to erase them. *. Some craters are so vast that entire cities could fit inside them. This massive crater is named Tycho, a relatively young impact site with bright rays extending outward for hundreds of kilometers. Copernicus and Plato are other giant craters, each one a testament to the violent history of our solar system. Every crater's name, every mark, every scar, is a story written in stone and frozen in time. This moon has faced countless meteor and asteroid impacts over its 4.5 billion-year existence, and it has preserved every blow as a marking on its surface, creating a historical record of impacts that scientists can study to understand the early solar system. Look at this spectacular view. Earthrise, you've seen moonrises and sunrises. But from here, from the moon's surface, something even more extraordinary is visible. A glowing blue planet full of life, alone, in the black void of space, making noise and light and life in the silence. That is our home. So small from this perspective, so delicate, like a fragile ornament hanging in the darkness. Seen from the moon, it feels like everything that has ever mattered is contained within that small war, history, future all, within this little blue drop suspended in the cosmic ocean. On the moon, sunlight falls directly without scattering because there's no atmosphere to diffuse it, no air to spread the light around, no wind to raise dust and create the soft, diffused lighting we're accustomed to on Earth. Therefore, every shadow is sharp as a knife's edge, deep, completely black, with razor-sharp boundaries. Every illuminated area is dazzlingly bright, almost painfully so. Here there's no middle ground between light and darkness, no gentle transition from day to night. Everything is either black or bright. Nothing in between. Like there's nothing between life and death. Similarly, there's nothing between sunlight and shadow here. It's a world of absolute extremes. The area we're looking at now is a part that humans have never physically touched. Although India's space agency, ISRO, successfully landed Chandrayaan-3 here in 2023, making India only the fourth country to achieve a lunar landing. But humans themselves have never set foot in this specific region. This is the moon's far side, the far side of the moon, which is never visible from Earth due to tidal locking. No human-made objects in this area except for a few robotic visitors. No signals reaching back to Earth directly. Only silence, profound and complete. A mystery that remains forever unsolved until more missions arrive. This area feels like a labyrinth from some ancient chapter of the universe, where silence itself is the only language, where quiet is the only conversation. The pervasive peace seems to write everything that needs to be said without words. There's something profoundly moving about this untouched wilderness, this place that has remained virtually unchanged for billions of years. Now we're passing over the area where Neil Armstrong and Buzz Aldrin first set foot on the moon, on July 20, 1969. The traces of the Apollo missions remain footprints, equipment, flags, landing modules. In the airless environment, these traces will remain undisturbed for millions of years unless disturbed by future visitors or micrometeorite impacts. The astronauts' bootprints are as fresh today as the day they were made over half a century ago. The flags still stand, though the harsh solar radiation has likely bleached them white by now. The atmosphere among observers is one of contemplative silence. Eyes are moist with emotion. It's because of the profound realization of being among the very few who have seen the moon this closely. who have made this journey across the vast gulf of space. Most of life's important lessons were learned by looking at the moon from Earth. Lessons about cycles, about change, about persistence, about beauty in the darkness. Now when it's so close, tangible, real, it feels like meeting an old friend face to face for the first time. Like finally embracing someone known only through letters and photographs. Asterisk, but more time cannot be spent here, as appealing as it might be to linger. Even though the moon is connected to childhood memories, to countless nights spent gazing upward and dreaming, to the mythology and poetry of every human culture, the journey must continue forward. The moon is being left behind now. It's getting smaller in the rear view, receding into the distance. But the picture of its craters, its lines, its shadows is etched permanently in memory, impossible to forget. Asterisk, the journey continues forward, toward Mars, toward Jupiter, toward the outer reaches of the solar system and beyond. But this silent meeting with the moon will remain forever as a treasured memory. The moon was seen up close, and it observed the passing visitors in return. And in that one extended moment, there was more than just traveling, there was witnessing. There was understanding. There was a connection across the void. A witness to the universe. A witness to life. The moon knows something profound, that there is someone who sees it every day from that blue world, who has watched it for millions of years, but rarely comes to visit in person. Journey to Mercury. Attention travelers. Now the moon's boundaries are being left behind, and the trajectory is set toward a planet, the innermost world of our solar system. The temperature is rising noticeably. Equipment is heating up. Thermal sensors registering the increasing radiation. But there's no need for concern because the spacecraft has sophisticated systems designed to handle both extreme heat and extreme cold, maintaining a comfortable environment inside regardless of external conditions. Asterisk, look ahead. A small dot-like planet is appearing on the horizon, growing slowly larger as the distance closes. This is it. This is Mercury. This planet is the Sun's most loyal companion, the closest of all planets and perhaps the loneliest too. Often at great heights, in positions of prominence, there is isolation. That's why achieving great heights only has meaning when the company of loved ones isn't lost in the process. But Mercury has no choice. It's locked in its close orbit, forever circling the Sun at a distance of only 58 million kilometers on average. Asterisk, what appears ahead is Mercury, a planet that looks somewhat like the moon but much more scorched, much more tortured by proximity to the Sun's fury. No clouds soften its surface, no air, no protective atmosphere. The surface is covered with impact craters, but here the shadows are even sharper, the contrasts even more extreme than on the moon. Mercury is the smallest planet in the solar system, even smaller than some of the moons orbiting other planets, yet its loneliness is vast and profound. It's like a solitary sentinel, standing guard at the gates of the solar system. Asterisk, here, the daytime temperature soars to 430 degrees Celsius, hot enough to melt lead, hot enough to make tin flow like water. And at night, when the sun's warmth cannot reach the surface, the temperature plummets to minus 180 degrees Celsius, a swing of over 600 degrees. This is one of the most extreme temperature ranges in the entire solar system. Asterisk, we're hovering above Mercury's surface now. What's visible through the window is the planet itself and its massive crater called the Calaris Basina crater. So enormous, it's hundreds of kilometers wide, created by a cataclysmic impact billions of years ago. Nearby are scattered rocks and cliffs, silently testifying to that ancient violence. The soil appears melted in places, vitrified by the heat of impacts. Asterisk, Mercury has no atmosphere to speak of. No wind to erode features. No rain to wear them down. Nothing here gets erased by time. Whatever marks are left on this planet remain for billions of years, unchanged, pristine, frozen in time. It feels like time itself has stopped here, and observers are becoming witnesses to that frozen moment, that eternal present where nothing changes and nothing fades. Asterisk, now the spacecraft edges slightly closer to the sun, but cannot go further because the sun's brilliance is beyond endurance. So intense that eyes would be in pain even through protective filters. The radiation levels are extreme, but there's no sound here, as there's no medium to carry sound waves. Mercury has no protection, no ozone layer, no magnetic field worth mentioning. Every ray of the sun falls directly on the exposed surface with full force. To protect the spacecraft, it's equipped with heat shields, reflective surfaces, and active cooling systems. This is a place where an unprotected human body would be destroyed in moments, where the human form would literally cook on the day side and freeze on the night side. Asterisk, but our machines are functioning, speaking through their sensors, seeing through their cameras, and signaling that it's time to leave this inhospitable place. On Mercury, one day the time, from sunrise to sunrise, is as long as 59 Earth days. And 1 year, one complete orbit around the sun, is only 88 Earth days. This creates a strange situation where days are longer than years, where the planet rotates so slowly that the sun seems to crawl across the sky. Asterisk, when the sun rises on Mercury, it spreads across the entire sky like a wall of fire, dominating everything, filling half the visible universe. Here the sun appears huge, about 3 times larger than it appears from Earth, a vast, blazing orb that dominates the sky. When night arrives after the long, torturous day, it feels like all the heat has been sucked away by some cosmic drain, leaving only icy death behind. On Mercury, every day is a battle between life and death, between fire and ice, between extreme heat and extreme cold. But nobody wins this battle. Only the balance between fire and ice maintains itself in an eternal stalemate. Asterisks between these two extremes. There's no place where life could find compromise. No middle ground where water could remain liquid, where complex chemistry could occur, where life, as we understand it, could take hold. Look at this on Mercury's surface. The shadow of our spacecraft is visible, cast by the sun's intense light, a faint black mark on the scorched ground. So close to the sun, that shadow is a sign for Mercury that someone was here, that visitors came from the distant blue world. Mercury says nothing, offers no response, and simply watches in its eternal silence, as if it knows that this meeting, though wordless, is historic. This barren world has been visited by human-made machines, has been seen and studied and understood, at least partially. Asterisk, now the spacecraft is exiting Mercury's orbit, leaving this tortured world behind. Look, the planet getting smaller behind us through the window is now just a brown dot against the black, shrinking with each passing second. But its loneliness, its scorched shadows, its patience and endurance echo within consciousness. Mercury showed us that even the smallest planet in the solar system can tell a profound story, can teach lessons about extremes, about survival, about enduring in impossible conditions. Asterisk, the spacecraft has left Mercury's orbit behind. Although the Moon and Earth lie along the route back and could be visited, the journey must continue forward into the unknown. This is an infinite journey, one that cannot be turned back from too soon. Journey to Venus. This planet ahead is Venus, named after the Roman goddess of love and beauty. Just approximately 41 to 61 million kilometers away from Earth. This distance varies constantly as both planets orbit the Sun. Venus is often called Earth's sister planet due to similar size and composition. There was a time when it was thought to be a second Earth, a world where life might flourish. But today, it's a mystery hidden in golden haze, a world made of fire, sulfur, and crushing pressure, a cautionary tale of planetary evolution gone wrong. Asterisk, as we approach this planet, what appears before the spacecraft is a world covered in shimmering, impenetrable clouds. No craters are visible from this distance. No surface features, no mountains or valleys, just thick, yellowish, poisonous clouds swirling in the dense atmosphere. Poisonous, yes, Venus's atmosphere is filled with carbon dioxide, over 96% of it, making it extraordinarily dense. The atmospheric pressure at the surface is 92 times greater than Earth's, equivalent to being nearly a kilometer underwater in Earth's oceans. And the temperature is above 465 degrees Celsius across the entire surface. Day and night. Poles and equator hot enough to melt lead, hot enough to destroy most metals. Asterisk, Venus is watching our approach. But there's no moisture in its atmosphere that could support life, only fire and acid. Here the clouds aren't made of water vapor, like Earth's beautiful white clouds, but of sulfuric acid, concentrated battery acid floating in the sky. The temperature here is so extreme that the robotic landers are the only option for exploring Venus's surface. Crewed missions are impossible with current technology. Asterisk, strong winds blow at 330 kilometers per hour in the upper atmosphere, circling the planet in just 4 Earth days, even though the planet itself rotates incredibly slowly. But near the surface, everything becomes heavy and slow, the thick atmosphere making movement difficult, like trying to walk through a thick ocean of honey or molasses. Asterisk, Venus's atmosphere doesn't just burn, it crushes as well. Every second would feel like an invisible hand pressing down, like an elephant standing on your chest. The Soviet Venera landers that successfully reached the surface survived only minutes to hours, before being destroyed by the combination of heat, pressure, and corrosive atmosphere. Asterisk, upon hypothetically landing on the surface below, everything appears orange through the thick atmospheric filter. The massive blanket of clouds transforms sunlight into a hazy, dim, yellow-orange glow. All around are signs of volcanic activity, frozen lava rivers, broken mountains, and silently scattered ash. Nothing here is green, neither is the sky blue, nor the ground cool. Here there's only a strange dream of browns, oranges, and thick golden colors, a landscape from a nightmare. Asterisk, can anything be heard here? The atmosphere is so dense that sound would travel differently, but Venus itself is silent. It has no voice of its own, only the echo of crushing pressure, the rushing of the dense wind, and the signals from our machines monitoring conditions. On Venus, every moment feels like the planet wants to say something, wants to tell its story, but the heavy atmospheric blanket makes its voice mute, suppresses whatever tale it might tell. Asterisk, there was a time when scientists thought Venus might have water, might have oceans, might have life. Some even speculated about microbial life floating in the cloud layers where conditions are less extreme. But as science advanced, as more data came back from orbital missions and landers, Venus revealed itself as a world where the greenhouse effect ran wild, where water was lost to space, where whatever chance for life existed was extinguished billions of years ago. Asterisk, Venus is a warning for USA. Stark reminder that if atmospheric composition is disrupted, if greenhouse gases run rampant, even a life-bearing world can transform into hell. Earth could follow a similar path if not careful with climate and atmosphere. This is what makes Venus so scientifically important. It shows us what happens when a planet-sized greenhouse effect spirals out of control. Asterisk, there isn't much more to see here on this planet's surface. The view is monotonous, oppressive, unchanging. The journey must continue, as there's a long way ahead into deeper space. We're leaving Venus behind now. Asterisk, the spacecraft is exiting Venus's orbit. Left behind is that golden ball that rises as the brightest planet in Earth's sky every evening or morning. That evening star and morning star that ancient peoples worshipped and modern peoples barely notice. It appears star-like to us from Earth, but now we know what lies behind that brilliant glow, a storm of heat and pressure. Deep pain, a world that could have been like Earth but took a radically different path. Asterisk, Venus still appears the most beautiful planet from Earth, but that beauty is dangerous, terrible, frightening, like a rose flower whose petals are made of hot iron and whose thorns are dripping molten lava. Beauty and horror combined in one package. Asterisk, now, our spacecraft has left Venus behind completely. From here, the sun's light begins to dim slightly as we move further from the inner solar system. The heat that was so feared in space is now transforming into cold, the deep cold of the outer reaches. Profound cold and strange peace spread everywhere. Asterisk, but slowly. Gradually, a new planet is appearing ahead on the trajectory. Yes, this is Mars, the red planet. Its distinctive red color makes it stand apart from other planets, and this color has become its complete identity throughout human history. This planet was once similar to Earth in many ways. Scientists say there was life here, or at least conditions suitable for life. Now it has become a cold, desolate, and mysterious world. A place where water once flowed but flows no longer. Asterisk, look through the window, that crimson-red planet approaching. This is Mars. Around it is a thin atmospheric layer that makes it feel partially protected, barely covered. Like wearing a thin blanket on a cold winter night. It appears to cover you, but still doesn't protect from the temperature's assault. Between Earth and Venus in terms of atmospheric thickness, Mars has just a whisper of air. But somewhere, there's this sense that at one time, life existed here. Now it's lost somewhere in the past, buried, perhaps beneath the rusty soil. Journey to Mars, the red planet. Asterisk, on Mars's surface, ancient volcanoes and vast canyons are visible, even from orbit. This planet was once warm and wet, covered with rivers and perhaps oceans. But now what remains is an icy, dry world. A desert planet where water exists only as ice and perhaps as subsurface liquid in certain locations. Was there life on this planet? Will signs of life ever emerge from here? These questions drive much of Mars exploration. Asterisk, the spacecraft approaches a landing point. On Mars's surface, light red dust is visible, blowing slowly in the thin wind. The air here is very thin, less than 1% as dense as Earth's atmosphere, and attempting to breathe here would be like trying to breathe at the summit of Mount Everest without oxygen. Except much worse. It feels like someone has removed all the essential elements from the air, leaving only the faintest wisps of mostly carbon dioxide. Asterisk, Mars's atmosphere is composed mainly of carbon dioxide, and the atmospheric pressure is much less than Earth's, only about 0.6% of Earth's pressure at sea level. But still, there are some remarkably attractive features visible that draw the eye and captivate the imagination. Asterisk, Olympus, Mons, the solar system's largest volcano, towering 22 kilometers above the surrounding plains. Yes, in the entire solar system, this is the tallest known volcano, larger than any mountain on Earth by a significant margin. Mars, despite being so far from Earth, seems to be saying something in its silence. I once witnessed life, or at least the potential for it, but couldn't preserve it. But you should preserve yours. Now I'm just silent, waiting. Asterisk, will we be able to break that silence? Or will we, like Mars, one day become similarly quiet and barren, our own world transformed into a cold desert? Asterisk, our spacecraft is now approaching Olympus Mons, up close. This volcano is 22 kilometers high, taller than Mount Everest, taller than any terrestrial mountain. Before it, even the largest mountains on Earth appear small, insignificant. Seeing it creates the impression of a vast mountain range extending far into the distance. But it's just a single volcano, a shield volcano so large it would cover an area the size of Arizona or Poland. Asterisk, across Mars's surface, in many places, large canyon systems are visible in ancient channels that might have been carved by massive water flows. Perhaps water once flowed here in great rivers and streams. These could be remnants of that ancient life, traces of a time when Mars was a warmer, wetter, more hospitable world. Asterisk, from the summit of Olympus Mons, there's contemplation. Can life ever bloom again on Mars? Or are the memories of a water-adorned green world still imprisoned in some deep canyon, waiting to be discovered? Asterisk. Now we're approaching Mars's Valles Marineris, the largest canyon system in the entire solar system. This canyon is 4,000 kilometers long as the entire United States is widened up to 7 kilometers deep in places, with walls dropping away into shadowy depths. In some bygone era, rivers flowed here. Massive water reservoirs existed, and there were traces of life, or at least the chemical building blocks for life. Asterisk. Looking into this canyon creates the feeling of gazing into living history, a place that quietly tells its story. I once saw water, witnessed it flowing through me, but now I'm only dry and silent. Here the hope of life has extinguished like a fading dream. But perhaps somewhere, somehow, life existed on Mars, or might exist in the future. Perhaps in subsurface aquifers, perhaps as dormant microbes waiting for better conditions, perhaps as fossils waiting to be discovered. Asterisk. Landing on Mars's surface. The scene is currently dominated by red colors, no greens or blues, to soften the harsh landscape. But the eyes sense those hidden memories that are buried in Mars's silence, compressed beneath the layers of dust and time. In the haziness of the thin atmosphere, Mars's sunset becomes remarkably mysterious and beautiful. Asterisk. The sun, slowly sinking below Mars's horizon, changes from golden to pink to deep red, a sunset unlike any other place. Unlike any other planet in our experience, this is like a blessing from a lost world, a final goodbye from the day. Such a beautiful sunset. If only there were someone here to appreciate it fully, to take a photograph, to share this moment with others back on Earth. Asterisk. Now preparations are underway to leave Mars. This world has given us much to contemplate, much to wonder about. We've now seen Venus, Mercury, the Moon, and Mars. Mars, where life possibly once existed, has become a dead world in the present era. But within it, the signal of that ancient life remains forever alive in the geological record, waiting to be read. Asterisk. Mars has taught a powerful lesson that life, no matter how hardy, can one day come to an end if conditions change dramatically enough. But still, in some form or another, the search for life should always continue, because finding evidence of past life on Mars would revolutionize our understanding of biology and our place in the universe. Asterisk. Our spacecraft has now moved far from Mars. Behind us, a planet of red hue is shrinking, becoming smaller with distance. We're moving away from the sun now. The light is becoming dimmer, the solar radiation less intense, and spreading ahead is a light orange-brown sphere, growing larger as we approach. There it is. We've said goodbye to Mars, to the terrestrial planets, to the familiar inner solar system. Asterisk. Now before us is a giant, or rather a colossal planet Jupiter, which is filled with mysteries, and after which begins the next chapter of the solar system, the realm of the gas giants. Journey to Jupiter, king of the planets. As we move toward Jupiter, the sun's light continues to diminish. All around is deep darkness and extreme cold. On the spacecraft walls, a layer of frost has formed, making the distance feelable and real. The walls are cold to the touch, reminding us how far we've traveled from the sun's warmth. Asterisk. Over the intercom comes the voice of the mission specialists. We're now just 500,000 kilometers from Jupiter. Prepare yourselves. Prepare to enter a new world, to witness something beyond anything seen so far in this journey. Asterisk. Now it's before you. Jupiter, the solar system's largest planet. Its color, its bands, its swirling, storms, everything is beyond imagination. Beyond what was expected, even after seeing images and videos. This planet is made entirely of gas, hydrogen, and helium primarily. That means there's no surface to land on, no solid ground to stand upon. Asterisk. Visible is Jupiter's famous Great Red Spot, storm, so massive that 3 Earths could fit inside it. A hurricane that has been continuously raging for at least 350 years, possibly much longer. This isn't just a planet, it's a walking, churning storm, a weather system the size of a world. The winds here blow at 600 kilometers per hour, faster than the most powerful hurricanes on Earth. Asterisk. Jupiter holds within itself a completely different universe. Entering Jupiter's atmosphere would be nearly impossible and would certainly be fatal. Around it are thick layers of hydrogen and helium, getting progressively denser as you descend. As we get closer, this gas becomes thicker, heavier, more compressed. The atmospheric pressure is so extreme that if we attempted to descend inside, our spacecraft would be destroyed within seconds, crushed like an aluminum can under a hydraulic press. Asterisk. This is a planet that cannot even be touched, cannot be explored with conventional methods, but studying it can lead us to the universe's greatest mysteries, understanding planetary formation, understanding the early solar system, understanding how giant planets influenced their stellar systems. Asterisk. As we enter Jupiter's orbital space, visible are its 95+ known moons, though scientists keep discovering more. But the most prominent ones capture immediate attention. First is Io, the most volcanically active body in the entire solar system. Its surface is constantly erupting, explosions happening regularly. like a battlefield where fireballs are raining from all directions. Io's surface is yellow, orange, red, and white colors created by sulfur and sulfur dioxide ejected from over 400 active volcanoes. The tidal forces from massive Jupiter squeeze and stretch Io constantly, generating enormous internal heat that powers this volcanic inferno. Asterisk Europa is covered in ice. Appearing to sleep under a frozen blanket, it looks peaceful, serene, like a world at rest. But beneath this ice sheet of 15 to 25 kilometers thickness, there might be a deep ocean, possibly containing more water than all of Earth's oceans combined. Perhaps beneath this ice blanket, life is sleeping or stretching, waiting to be discovered. The smooth, relatively crater-free ice surface suggests that it's young, constantly renewed, perhaps by water welling up from below. Asterisk, Ganymede is the solar system's largest moon. Even bigger than the planet Mercury, it's the only moon known to have its own magnetic field, creating a miniature magnetosphere within Jupiter's massive one. Its surface shows both ancient dark terrain covered in craters and younger bright terrain with grooves and ridges, telling a story of complex geological history. Callisto is the most heavily cratered body in the solar system, its ancient surface recording billions of years of impacts. It's a mysterious moon that appears geologically dead on the surface, but might harbor a subsurface ocean like Europa. Asterisk, when observing Europa, the thought arises there an ocean beneath this ice. And if there is there life in that ocean? These questions drive some of the most exciting planned missions in space exploration. Future missions might drill through the ice or analyze plumes of water ejected from the surface. Asterisk, now the spacecraft passes near that place which millions of scientists yearn to observe directly, the Great Red Spot. This is a massive cyclonic storm containing ice, gas, lightning, and winds all mixed together in a chaotic dance. The spacecraft's walls are shaking from the turbulence, vibrating with the force of Jupiter's powerful magnetic field and the gravitational stresses. The pressure is intense, the readings on instruments fluctuating wildly, but the trajectory takes us over and around it, not through it. This planet's storms have continued unabated for centuries. This represents stable chaos, a turbulent ocean that appears calm from afar. Asterisk, it's time to turn back from this region because here there's nothing but destruction for anything that ventures too close. But it's worth knowing something remarkable. Jupiter acts as a cosmic shield for Earth. Many meteorites and asteroids, coming from the outer solar system, are captured by Jupiter's immense gravity and either absorbed or deflected. Jupiter holds them near itself, preventing them from reaching the inner solar system where they might impact Earth. In this way, Jupiter serves as humanity's protector, a guardian standing watch at the boundary between the inner and outer solar system. Asterisk, moving away from Jupiter now, it becomes clear that planets aren't just large in physical size. They're vast in emotions, in the hopes they inspire, in the search for the unknown they represent. Jupiter is like a guru, a teacher, who not only inspires Earth to move forward in the right direction, but also protects it from unknown dangers coming from space. Jupiter has shown that every question's answer isn't found only on solid ground. Sometimes it's hidden in the skies, in the swirling gases, in the alien atmospheres of worlds unlike our own. Asterisk, now we're leaving Jupiter's realm and heading to that planet which ancient peoples called the celestial jewel Saturn, whose rings make it unique among all planets in the solar system. # journey to Saturn. Lord of the Rings, our spaceship is emerging from Jupiter's orbit. But first, there's a stop at Europa, that small, shining moon that has captivated planetary scientists for decades. On its surface is a solid ice layer that sparkles in sunlight like a polished mirror. Outside, everything appears calm, completely still, frozen in time. But beneath this ice, there might be a vast ocean stretching tens of kilometers deep, warmed by tidal heating from Jupiter's powerful gravity. Asterisk, look outside the spacecraft window. Europa's surface has cracks, fissures, places where the ice has broken and reformed. In some locations, water or brine from beneath the ice has erupted outward like icy geysers, frozen mid-fountain. Scientists say that Europa's ocean might contain life forms similar to those in Earth's deep oceans, perhaps something like extremophile bacteria, perhaps something more complex. There's no proof yet, no definitive evidence, but the possibility remains alive, tantalizing, driving mission proposals and scientific papers. Asterisk, if life exists anywhere else in our solar system, it might be breathing beneath this ice, swimming in that dark ocean, feeding on chemical energy from hydrothermal vents on Europa's seafloor. The thought is simultaneously humbling and exciting. We might not be alone even within our own solar system. Asterisk, now Europa must be left behind as well. The destination is Saturn. The distance from Jupiter to Saturn is approximately 650 million kilometers, a vast gulf of space. The journey is long, taking years even at spacecraft velocities. But as we get closer, something extraordinarily beautiful becomes visible. Asterisk, around. Yellowish planet, and around it, spread out in majestic splendor, are gleaming rings composed of countless particles. It's as if someone has adorned a planet with the universe's most beautiful jewelry. Placing a cosmic necklace around Saturn's equator. Asterisk, our spacecraft is approaching Saturn. The rings appear impossibly thin, so thin that if you could stand them on edge, you could see through them, yet they're incredibly wide, extending approximately 280,000 kilometers from the planet, though only about 10 meters to 1 kilometer thick. Through these ice rings we must navigate carefully. Asterisk, these rings contain millions upon millions of pieces of ice, dust, and rock fragments ranging from tiny grains to house-sized boulders. Every single piece sparkles in the sunlight like diamonds, like jewels scattered across the cosmos. This view is like something from a dream, surreal and breathtaking. Saturn's rings move in a silent slow-motion dance, rotating like cosmic jewelry in the darkness. Asterisk, we're now above Saturn's atmosphere. This planet is entirely composed of gases. No solid surface exists to land upon, no ground to walk on. Hydrogen and helium form its primary composition, with traces of methane, ammonia, and other compounds creating the beautiful banded appearance. Nobody would think of attempting to land here because there's simply nowhere to land. Asterisk, the winds here blow even faster than on Jupiter, up to 1,800 kilometers per hour near the equator, faster than the speed of sound on Earth. The atmosphere contains gentle golden and yellow waves, swirling bands of clouds at different latitudes. There's no trace of ground beneath, no solid surface anywhere. If something fell into Saturn, it would keep falling deeper and deeper, experiencing increasing pressure and temperature until eventually it would be crushed and vaporized, becoming part of Saturn forever. Asterisk, Saturn is a colorful cloud whose depth is infinite for all practical purposes. This isn't a planet in the traditional sense. It's a wandering dream, a floating castle in the sky that has no foundation, no floor. This is the aerial palace that can be observed but never inhabited, admired but never touched. Asterisk, Saturn has over 145 known moons, and scientists keep discovering more. But two names stand out as particularly special and scientifically significant. Asterisk, first is Titan, Saturn's largest moon, and the only moon in the solar system with a thick atmosphere. Thicker than Earth's, in fact. Here, there are methane lakes and seas, not water, but liquid hydrocarbons. Mountains rise from hydrocarbon plains, and it rains liquid methane instead of water. Titan has weather, seasons, erosional, the processes that shape planetary surfaces, but using entirely different chemistry. If humans could visit anywhere beyond Mars, Titan might be among the first destinations. Its thick atmosphere would provide some radiation protection, and its surface pressure is only slightly higher than Earth's. Asterisk, second is Enceladus, a small white moon covered in pristine ice, but beneath its frozen surface, hidden from view, is another vast ocean. And from this moon, geysers erupt regularly. Plumes of water, ice and vapor shooting hundreds of kilometers into space from cracks near its south pole. These plumes have been detected and analyzed by spacecraft, showing that they contain organic molecules, salts, and other ingredients potentially necessary for life. This indicates that here too, beneath the ice, there might be conditions suitable for life. Asterisk, we're flying above these ice-covered worlds, beneath which oceans flow, hidden waters that might harbor life. Perhaps there are others like us who want to break through this layer and emerge outside, who are looking up at their ice ceiling, wondering what lies beyond. Just as we look up at our sky and wonder what lies beyond the stars. Asterisk, now comes the most thrilling part of this segment of the journey. The spacecraft is being navigated through the rings themselves. All around are glowing pieces of ice, and the sound being heard, though sound cannot travel in space, is translated from the vibrations as ring particles brush against the spacecraft's hull. Some pieces are small, some larger, all sparkling in sunlight like diamonds, like gems scattered through space. A peaceful music seems to play in this cosmic jewelry box. Asterisk, no words are adequate, no sound sufficient to capture this moment. Just brilliance and motion, beauty and mathematics combined. Some ring particles touch the spacecraft as it passes, gently brushing past. Perhaps they're saying, "We've seen you. We know you were here." Asterisk, from here, far from the inner solar system, no sound reaches us from the familiar worlds, but the universe's silence speaks volumes, communicates in ways that words cannot. This silence is pregnant with meaning, filled with the story of billions of years. Journey to Uranus and Neptune, the ice giants. Asterisk, now the trajectory leads toward the solar system's most mysterious, cold, and remote destinations, where even the sun's light becomes extremely dim, barely more than a very bright star. The destinations are Uranus and Neptune, two blue ice giants called the ice giants because, unlike Jupiter and Saturn, which are mostly hydrogen and helium, these planets contain significant amounts of water, methane, and ammonia ices in their interiors. Asterisk, so fasten seatbelts because we're heading to the solar system's blue boundaries. Two places so remote that spacecraft have visited them only briefly. The cold is going to intensify dramatically. Everything will be much slower, much colder here, and incredibly beautiful in an alien, otherworldly way. Asterisk, we emerge from Saturn's rings, leaving behind the icy moons and their golden silence. Now we're heading toward where the universe becomes even quieter, even more mysterious, even more remote from the sun's warmth. Asterisk, on the spacecraft's screen, the next destination is becoming visible, a pale blue-green dot slowly growing larger. This is Uranus, our next stop, approximately 2.9 billion kilometers from Earth. That's nearly 20 times Earth's distance from the sun. It's extraordinarily far from home. From the familiar warmth and light, caution is necessary here because any mistake could be catastrophic this far from the sun. Rescue is impossible. Help cannot arrive. Asterisk, before us is a pale blue planet Uranus, the solar system's seventh planet. This world is different from all other planets because its axis is tilted approximately 98 degrees from vertical. It appears to be lying on its side, rolling around the sun rather than spinning upright like a top. It's as if someone pushed it over billions of years ago, perhaps in a massive collision with another planetary body, and it's been rolling sideways ever since. Asterisk, the image is almost comical, like someone who's had too much to drink and can't stand straight, lying down instead. That's exactly what Uranus appears like, and now it's rotating on its side rather than upright. This means its poles alternately point toward and away from the sun as it orbits, creating the most extreme seasons in the solar system. Each pole experiences 42 years of continuous sunlight, followed by 42 years of complete darkness. Asterisk, Uranus's color is a pale blue-green, an ethereal shade unlike anything in the inner solar system. This color comes from methane in its atmosphere, which absorbs red light and reflects blue and green wavelengths. The temperature at the cloud tops hovers around minus 220 degrees Celsius, making it the coldest planetary atmosphere in the solar system, despite not being the most distant from the sun. Asterisk, here, there are 13 faint rings, much darker and less prominent than Saturn's spectacular ring system, and 27 known moons whose names are taken from the works of William Shakespeare and Alexander Pope. Literary names like Titania, Oberon, Miranda, Ariel, and Umbri. Observing Uranus is like reading poetry every moon. Every orbital characteristic tells a new line, inspires new imagination, suggests new stories waiting to be discovered. Asterisk, ## Neptune, the windiest world. Asterisk, now comes the solar system's final planet, Neptune, the eighth world from the sun, approximately 4.5 billion kilometers from Earth. As we approach, a deep blue planet grows larger before us, its size increasing steadily. It's like an ocean's depth has been captured and sealed inside a bottle, compressed into planetary form. Asterisk, strong winds blow here, the strongest winds in the entire solar system, reaching speeds of 2,100 kilometers per hour or more. That's faster than the speed of sound on Earth. Supersonic winds that would tear apart anything in their path. Neptune's winds create a sensation as if the universe itself is speaking, whispering secrets from the depths. A murmuring rising from the abyssal regions of space. Asterisk, Neptune's largest moon is Triton, one of the strangest objects in the solar system. It orbits in the opposite direction from Neptune's rotation or retrograde orbit. Perhaps it originally came from elsewhere, perhaps from the Kuiper belt, and Neptune's gravity captured it and forced it into orbit. This retrograde orbit means Triton is slowly spiraling inward, and in a few billion years, it will either crash into Neptune or be torn apart by tidal forces to form a spectacular ring system. Asterisk, on Triton's surface, ice volcanoes erupt, cryovolcanoes that spew nitrogen gas and ice particles instead of molten rock. From these vents, geysers of nitrogen gas shoot kilometers into space, visible as dark streaks across Triton's pink-tinged ice surface. This moon silently breathes icy breaths and holds within its frozen depths potential signs of life, or at least complex chemistry, hidden in the most remote corner of the solar system. Asterisk, and now we're about to cross a boundary called the heliopause, where the sun's influence finally ends, where the solar wind's pressure is balanced by the pressure of interstellar space. This is where interstellar space begins, the space between stars, the cold, empty, mysterious realm that separates our solar system from the rest of the galaxy. Asterisk, so tighten seatbelts even more, because we're heading to a place where only two human-made machines have ventured, Voyager 1 and Voyager 2. Those intrepid explorers launched in 1977 and still sending signals back to Earth from interstellar space. Asterisk, behind us remains Neptune and its moon Triton, those blue worlds at the edge of the planetary realm. Now before us comes the Kuiper belt, a vast ring of icy objects, rocky chunks, and small bodies that orbits beyond Neptune. This belt encircles the sun's boundary like a frozen moat around a castle. Asterisk, from here emerges Pluto, once considered the ninth planet, but now classified as a dwarf planet. Pluto and its moon Charon are almost the same size, and both orbit around a common center of gravity between them, like lovers holding hands and dancing together, circling each other in an eternal cosmic waltz. The place here is dark but fascinating. like a deserted desert where mysterious treasures are buried beneath the frozen surface. Asterisk. The temperature here plunges below minus 230 degrees Celsius. At this distance, the sun appears merely as a bright star, no longer a disk, no longer the dominant force it was in the inner solar system. As we continue forward, we reach that boundary where the sun's solar wind, that stream of charged particles flowing outward, is no longer effective, no longer dominant. Asterisk. This boundary is called the heliopause, the sun's final frontier, its last border before interstellar space begins. Here is where Voyager 1 crossed in 2012, becoming humanity's first ambassador to the space between stars, the first human-made object to leave our solar system's protective bubble. Asterisk. Into interstellar space. Asterisk. Now we're in interstellar space, truly between the stars. The space here where gas, dust, and the ash of ancient dead stars float in the near. The particles here are rare, sparse, with vast emptiness between them. But each particle has a story. Perhaps it came from an exploded star, a supernova that died billions of years ago. Or perhaps it's part of a forming planet somewhere, material that will someday coalesce into worlds yet unborn. Asterisk. Here, magnetic fields swirl and dance invisibly. Cosmic rays, high-energy particles from distant sources, float through space, penetrating everything in their path. Gravity creates structure even in this emptiness, pulling matter together over incomprehensible timescales and distances. This place is neither silence nor noise in any conventional sense. It's a slow symphony, a gradual composition that plays the universe's music on timescales of millions of years. Asterisk. Now we can see ahead a faint light coming from the sun's nearest neighboring star system. That's Proxima Centauri, our closest stellar neighbor, at 4.24 light-years away. Even at tremendous spacecraft velocities, reaching there would take thousands of years with current technology. It's a journey beyond current human capabilities, beyond our technological reach, though not beyond our dreams and aspirations. Asterisk. Proxima Centauri has a planet called Proxima b, discovered in 2016, orbiting in the habitable zone where liquid water could exist. Perhaps that world could support life similar to Earth's disk. Maybe there's someone there looking back toward us, wondering if they're alone, contemplating the same questions we ask ourselves. Or perhaps they too have ventured out into space, searching for others like them, explorers from their world, just as we're explorers from ours. Asterisk. So now, having left the solar system behind, having crossed the we're on the universe's open highway. The vast spaces between stars, the familiar yellow dwarf star called the Sun, is now just one star among billions visible in the sky, no longer special from this perspective. No longer obviously our home star, except that we know which one it is. The infinite cosmos awaits. Asterisk. But now comes an important question. Are you ready to journey into the world of exoplanets? Those planets orbiting other stars, where millions of stars have countless planets waiting to be discovered, studied, understood, where every new discovery rewrites what we thought we knew about planets, about solar systems, about the universe itself. Asterisk. The journey has taken us from Earth through the inner rocky planets: Mercury with its scorched surface, Venus with its hellish atmosphere, Mars with its ancient dried riverbed. We've witnessed the moon's cratered face, seen Earth rise over the lunar horizon. We've traveled past the asteroid belt into the realm of gas giants: Jupiter, with its massive storms and fascinating moons, Saturn with its incomparable rings and mysterious Titan. Asterisk. We've visited the ice giants, Uranus and Neptune, in the outer darkness, seen their exotic atmospheres and strange moons. We've crossed the Kuiper belt where Pluto dances with Charon, and we've passed through the heliopause into true interstellar space, that realm between stars where Voyager still travels. Asterisk. Each world taught lessons: Mercury about extremes and endurance, Venus about greenhouse effects gone catastrophic, Mars about lost oceans and the fragility of atmospheres, Jupiter about cosmic protection and complex moon systems, Saturn about beauty and dynamics, Uranus about the unexpected and unusual, Neptune about the power of planetary winds. Asterisk. The moons were equally instructive: our own moon about impact history and tidal locking, Europa and Enceladus about subsurface oceans and the possibility of life beyond Earth, Titan about complex organic chemistry, Triton about captured objects and cryovolcanism. Asterisk. Every crater, every storm, every ice geyser, every ancient riverbed tells a story. Every planet is a chapter in the universe's book, and we're just beginning to read these chapters, just starting to understand the grammar and vocabulary of planetary science. Asterisk. Space is not empty, it's full of structure, history, potential. The distances are vast beyond human comprehension, measured in light years and parsecs, in units that dwarf anything in human experience. The timescales are equally vast: billions of years during which stars are born, live, and die, during which galaxies form and collide, during which the universe itself expands and evolves. Asterisk. We're cosmically young, our species having existed for only a tiny fraction of cosmic history. Our technology is primitive compared to what might be possible. Our understanding is incomplete. filled with questions we don't yet know how to answer. But we're learning, exploring, pushing boundaries. Asterisk, the spacecraft continues outward. Instruments still functioning. Sensors still gathering data. Every moment brings new information, new measurements, new insights into the nature of interstellar space. The solar wind's pressure has dropped to nearly nothing. The galactic cosmic ray flux has increased. The plasma density has changed character. The magnetic field orientation has shifted. Asterisk, these measurements tell stories about the boundary between our solar system and the galaxy beyond, about the transition from our sun's domain to the wider Milky Way, about the nature of the interstellar medium that fills the spaces between stars. Asterisk, ahead lie more stars, more solar systems, more planets. Some of these planets have been detected from Earth through various methods. The transit methods, where planets are seen crossing in front of their stars. The radio velocity method, where stellar wobbles reveal planetary presence. Direct imaging, where powerful telescopes actually photograph the planets themselves. Asterisk, thousands of exoplanets have been discovered, and each one is unique. Hot Jupiters orbiting impossibly close to their stars, completing orbits in days. Super-Earths larger than our world but smaller than Neptune. Planets in multiple star systems where multiple suns rise and set. Planets orbiting dead stars. Planets free-floating through space without any star at all. Asterisk, some orbit in habitable zones where temperatures allow liquid water. Some might have atmospheres rich in oxygen. Some might have continents and oceans. Some might harbor life, perhaps simple microbes, perhaps complex ecosystems, perhaps even intelligent civilizations, looking up at their own skies and wondering if they're alone. Asterisk, the search for life beyond Earth is one of humanity's greatest quests. It drives mission proposals, telescope designs, scientific research. Finding even simple life elsewhere would revolutionize biology, philosophy, theology. Finding intelligent life would transform human civilization, forcing us to reconsider our place in the cosmic hierarchy. Asterisk, but even finding nothing would teach us something. It would suggest that life is rare, precious, worth protecting. It would emphasize our responsibility to preserve Earth's biosphere, to prevent the kind of environmental catastrophe that might have struck Mars or Venus. Asterisk, looking back toward the sun from this distance. Earth is invisible, hidden in the glare of sunlight, too small and dim to be seen directly. Carl Sagan called it the pale blue dot in his famous reflection on the Voyager 1 photograph taken from beyond Neptune. That pale blue dot contains everything humans have ever known, every person who has ever lived, every civilization that has risen and fallen, every war fought and peace achieved, every love story and tragedy, every scientific discovery and artistic masterpiece. Asterisk, all of human history has occurred on that tiny world, that mote of dust, suspended in a sunbeam. All our conflicts, all our perceived importance, all our imagined greatness confined to that minuscule stage. Yet from that tiny world, we've reached out. We've built machines that cross the solar system and enter interstellar space. We've peered across billions of light years to see the early universe. We've begun to understand our cosmic origins. Asterisk, we're made of star stuff, as Sagan noted. The atoms in our bodies were forged in stellar cores and scattered across space by supernova. The carbon in our cells, the oxygen we breathe, the iron in our blood, all created in stars that died before our sun was born. Where the universe become conscious of itself. Matter organized in such a way that it can contemplate its own existence. Asterisk, the journey continues outward into the unknown. The spacecraft's power will eventually fade. Its radioisotope thermoelectric generators producing less and less electricity as their plutonium decays. Communications will become more difficult as distance increases and signal strength decreases. Eventually, silence will fall as the last signal is transmitted and received. Asterisk, but the journey won't truly end. The spacecraft will continue moving through interstellar space for millions of years, perhaps eventually passing near other stars, perhaps being caught by gravitational fields, perhaps wandering the galaxy until the sun itself dies billions of years from now. It carries messages from Earth, images, sounds, greetings in many languages, music from various cultures. If it's ever found by another civilization, they'll know that once, on a planet orbiting an ordinary star, life arose and became intelligent and curious and brave, enough to send ambassadors to the stars. Asterisk, this is the story of exploration, of curiosity, of the urge to see what lies beyond the horizon. It's driven humans to cross oceans, climb mountains, explore poles, and venture into space. It's fundamental to human nature, this desire to know, to understand, to push boundaries. Asterisk, the universe is vast, ancient, complex, and beautiful, beyond description. It operates according to physical laws that we're still discovering, still understanding. It contains structure on every scale, from subatomic particles to galaxy superclusters spanning billions of light. It's been expanding for 13.8 billion years, since the Big Bang, evolving from a hot, dense state to the cooler, more structured cosmos we inhabit today. Asterisk stars form in nebulae, massive clouds of gas and dust that collapse under their own gravity. As they collapse, they heat up, eventually igniting nuclear fusion in their cores. They shine for millions or billions of years, depending on their mass, fusing hydrogen into helium and heavier elements. Eventually, they die small stars like our sun, becoming white dwarfs, massive stars exploding as supernova, the very largest becoming black holes. Asterisk planets form from the leftover material, the disk of gas and dust that surrounds young stars. Small particles stick together, gradually growing larger through collisions and gravitational attraction. Rocky planets form close to the star where it's hot enough that only rock and metal can condense. Gas giants form farther out where ESIS can exist and where there's enough material to build massive atmospheres. But every planetary system is different, shaped by countless random factors: the initial composition of the nebula, the presence or absence of nearby stars, the timing and nature of planetary migrations, the impacts that reshaped worlds. Our solar system is just one example among billions. One arrangement among countless possibilities. Asterisk. The diversity of exoplanets discovered so far suggests that planetary systems come in endless variety. There are likely billions of potentially habitable planets in our galaxy alone. Billions of places where life might arise. Whether it actually does arise is unknown. We have a sample size of one, just Earth. But the chemical building blocks of life seem to be common throughout the universe. Organic molecules have been found in interstellar space, in comets, on asteroids. The ingredients are present. Whether they combine into living systems elsewhere remains to be discovered. Asterisk. The search continues through multiple methods. Telescopes scan the skies looking for chemical signatures in exoplanet atmospheres, oxygen, methane, compounds that might indicate biological processes. Missions are being planned to explore Europa and Enceladus, to search for life in their subsurface oceans. Rovers continue exploring Mars, looking for fossil evidence of ancient life. Asterisk. Radio telescopes listen for artificial signals, for broadcasts from distant civilizations. So far, silence, but the search has barely begun, covering only a tiny fraction of possible frequencies, directions, and signal types. Perhaps we're alone in the galaxy, or perhaps we simply haven't looked in the right place at the right time yet. Asterisk. The universe is approximately 93 billion light-years in diameter, containing perhaps 2 trillion galaxies, each with hundreds of billions of stars, each star potentially hosting planets. The numbers are so large as to be meaningless in normal terms. If life is rare, there might still be millions or billions of inhabited worlds. If life is common, the universe might be teeming with it, full of biospheres at every stage, from simple chemistry to complex ecosystems to technological civilizations. Asterisk. We stand at the beginning of this exploration. Taking our first tentative steps beyond our homeworld, we've sent probes throughout our solar system. We've landed humans on the moon. We've operated rovers on Mars. We've detected thousands of exoplanets, but we haven't yet found definitive evidence of life beyond Earth, haven't yet made contact with another intelligence, haven't yet fully understood our place in the cosmic story. Asterisk. That understanding will come gradually, through continued exploration, through better telescopes and spacecraft, through missions to moons and planets, through dedicated searches for biosignatures and technosignatures. Each generation will add to our knowledge, will answer questions and raise new ones, will push the boundary of the known a little further into the unknown. Asterisk. The spacecraft continues its journey, now a permanent resident of interstellar space, now part of the galaxy, rather than just the solar system. It's a symbol of human achievement, of scientific progress, of the exploratory spirit. Billions of years from now, when the sun has become a red giant and then a white dwarf, when Earth has been rendered uninhabitable, when humanity has either spread to the stars or ceased to exist, these spacecraft will still be traveling, still carrying their messages, still representing a moment when a young species looked up at the stars and decided to visit them. Asterisk. This is just one moment in the universe's vast history, one chapter in an incomprehensibly long story. But it's our moment, our chapter, our chance to explore and understand and appreciate the cosmic stage we inhabit. The journey outward is also a journey inward, teaching us about ourselves, about our origins, about our future possibilities. Asterisk. The cosmos awaits, infinite and mysterious and beautiful. Every star is a sun, potentially with its own planets. Every galaxy contains billions of stars. Every observation reveals new wonders. Every mission teaches new lessons. Every discovery raises new questions. Asterisk. Where will this journey ultimately lead? Will humanity spread to other worlds, becoming a multi-planet species? Will we discover life elsewhere, learning that biology is universal? Will we make contact with other civilizations, joining a galactic community, or will we remain alone, unique, the universe's only way of knowing itself? Asterisk. These questions drive exploration forward, motivate research, inspire dreams. The answers lie ahead, in the vast cosmos that surrounds us, in the infinite possibilities that await discovery. The journey has only just begun.